Recording this and putting it on.
Okay, first problem. We have two triangles here. You can kind of see the outline there and then over here. And we're trying to find the distance between these two. So we're looking at this triangle ultimately in the end. A lot of mess there, but. So I've got two right triangles, which I'm going to just draw separately. One is 47 degrees, one is 45 degrees. I know the height of the tower is 1100, so I can find this hypotenuse of one and this hypotenuse of the other. Let's make this x and y. And then I'll end up with this triangle here that has x on one side, y on the other, and 50 degrees. Does that make sense? Okay, I need a calculator. I have one.
I'll be done tomorrow, Brother.
Okay, so this is cosine is equal to 1100 over x, and then cosine here. So I would just take 1100 divided by cosine 47 to get this one. And then 1100 divided by cosine 45 to get this one, 6.3. Now I've got this triangle to solve, and I know this is 1621.91, and this is 0.63. And I'm looking for the distance between the two towers. So I'm going to use law of cosines. It's up here in the purple. And that goes, the side I'm looking for, squared, is equal to one side squared plus the other side squared minus 2 times one side times the other, 5.63, cosine 50. I just plugged it right into the formula. So 1621.91 squared plus 1555.63 squared minus 2 times 15 times cosine 50. And I get a big number that I then take the square root of, and I get 1340.
How did you get 15?
I thought that was the angle between the two.
Did it give us that?
Yeah.
Oh, I just can't see.
Right there. Yep. So this one, we learned law of sines and law of cosines in geometry. I'll leave the sign up. I can't remember if there's a law of cosines question on the test, but if there is, you can just plug it in. Just one side squared plus another side squared minus 2 times this side times cosine of that is all right there. You just plug it in. All right. Maybe I can get my board to work. Okay. Point P is on the unit circle. And we're told it's in quadrant 2, and my board's not cooperating. So I always just draw my triangle. The x-coordinate is really what? Sine or cosine? Cosine. So I could just go ahead and, in my triangle, make it cosine. I'm trying to find the y-coordinate, so I'm just going to take 49 minus 4 is 45, and the square root of that. So the y-coordinate must be the square root of 45 sevenths. The x-coordinate's what they gave me, so it's got to be this one. Another terminal point, t plus pi. So this is t, and 4/7, so this is 4, this is 7, this is the square root of 33. Everybody see how I did that? Okay. If I'm going to add pi, this is still t, but now this is negative, and this is negative. And I'm trying to find the terminal point. So it's going to be the same thing, but they're both going to be negative. Reference number for 5 pi over 4. Well, 5 pi over 4 is 1 pi over 4 more than 180. That makes sense? Because 180 is 4 pi over 4. So this must be pi over 4. So the reference angle is just pi over 4. Reference is the acute angle in each quadrant. Rewrite 1400 in radians. So I'm going to divide it by 180, multiply it by pi. 1 0 cancels. That becomes 70 over 9 pi. If tangent's positive and sine's positive, what quadrant am I in? Yep. And tangent is 7 for 24, so that means this is a 7, 24, 25 triangle. Exact value of sine is just 7 over 24. Coterminal angles for negative 120. Negative 120 sits here, which means this is 60 degrees. So if I wanted to go the other direction, be 180 plus 60 is 240. Still good? Let 2, negative 4 be a point on the terminal side of an angle. So that means it's in the third quadrant. And this is negative 2, this is negative 4, which means square root of 20. And I'm trying to find the exact value of secant. Well, secant's the inverse of cosine. So it would be square root of 20 over negative 2. This simplifies to 2 square roots of 5. So it's just the negative square root of 5. Good. Okay, this one, anytime you see a problem that you need to simplify, just get everything in terms of sine and cosine. So secant is 1 over cosine. Sine is just sine, but I'm going to put it over 1. Cotangent is cosine over sine. And then cosecant is 1 over sine. And then I'm just going to cancel what I can. What I have left is cosecant. Make sense? Okay. If secant is negative 5/4 and it's in the third quadrant, secant is 1 over cosine. Find tangent 3/4. If the angle is pi over 3, that's 60 degrees. So let's just go ahead and complete a 60 degree. This would be 1, 2, square root of 3. And I'm going to add pi to it. So it's going to be right back here. This is reference angle is still pi over 3. So this becomes, and I'm finding sine. It would be negative square root of 3 over 2. Okay. So if I have cosine theta, I'm going to make one up. Cosine theta equals 4/5. I add pi to that. This is theta plus pi. Well, the reference angle is still the same. So this becomes cosine of theta plus pi is negative 4/5. Negative 4/5. So that would be just the opposite of what cosine was in the first quadrant. Y is 55. That's opposite the 30, which means the hypotenuse is 110. Now I have a 30, 60, 90 big triangle. I'm trying to find the hypotenuse. Well, to go from the side opposite the 60 to the 30, I divide by the square root of 3. And then to go from the 30 to the hypotenuse, I double that to 20. And then just put that in the calculator and you get 127. An airplane is flying at an elevation of 5,300 feet. And two cars on opposite sides of the plane. One is an angle of depression of 31 and the other is 53. And this is 5,300. And it wants to know the distance between the two cars. So I'm going to just find x and y in the triangles. Tangent. And then this one is tangent 53. And then just solve. So 5,300 divided by tangent 31 is 8820.7. And 5,300 divided by tangent 53 is 3993.8. When I add those two together, I get 12,815. Question on that one?
Isn't the angle of depression the top angle?
It's this angle, which is the same as this one,
Oh.
because it's alternate interior angles between two parallel lines. Yep. Okay, this one you had to go back into section 2 maybe, page 5, to find the equation of the area. Let me draw this triangle. If you know A and B and the included angle, that's the formula for the area of a triangle, if you know those two things. So without knowing an altitude, there's no other way to do it than using this formula. So A is 9, B is 13, and the included angle is 56. So I just take 9 times 13 times sine of 56, divide that by 2, and it's 48.5. Last page. 21-foot ladder. Maybe it's not the last page. Leans against a building. Maybe. Come on. And the angle between the ground and the ladder is 68 degrees. How high does the ladder reach on the building? So that's just sine. Sine 68 times 21. 19.47, so the nearest foot would be 19 feet. And then, again, I'm just going to break this into two right triangles, find A and B and add them together, right? So sine, no, cosine, nope, tangent equals 90 over A, and then I have tangent 27 equals 90 over B. So 90 divided by tangent 63, this one is 45.86, and then I have 90 divided by tangent 27, which is 176.63, and add those together to get 222.49. This one I think is easiest. First off, if it's given to me in radians, this answer for B needs to be, this one needs to be in radians too. So I know the two added together have to be 90, which is pi over 2, right? So I'm going to take, 5 pi over 2, over 10, sorry, minus pi over 10, and that's 4 pi over 10, which is 2 pi over 5. So this one is 2 pi over 5. Now that I've done that, I'm going to go ahead and convert this to 18 degrees, just to make my life a little easier. So now I'm trying to find A. Well, in terms of this angle, it's cosine equals A over 43.8. Cosine 72 times 43.8 is 13.5 to 2 decimal places, 5.3. And then B is going to be sine. So sine 72 times 43.8, 41.66. Point P is on the unit circle. The coordinate is, the x coordinate's negative, y coordinate's positive, so it's got to be in this. The y coordinate is 10 over 11, so this must be square root of 21, negative. And I'm finding the coordinate. So it's, no, what am I finding? I don't know. I'm finding the coordinate. So it's negative square root of 21 over 11, comma, 10 over 11. That's the point P. Laser beam. So we have the Earth, we have the moon, we have some laser beam that's originally going towards the center, but it gets off kilter. And this is 50.55 degrees. The distance from the Earth to the moon is 240,000 miles. And we're trying to find how far off it is. So that's going to be tangent equals x over 240,000. 0.55 times 240. 2303.9 miles. The radius is 1,000, so definitely misses the moon. And then the bonus. So I can take this equation and make it y equals 2x. Does everybody see that? I just add y to both sides. So y equals 2x has got a slope of 2 to 1, right? So it's going up 2 over 1. But this tells me it's in the third quadrant, so it's going to go down 2 over 1 in the third quadrant. And I want to find cosine. So this is going to be the square root of 5. Cosine of this angle is negative 1 over the square root of 5, which when I calculate that to the 10,000ths, that's it. I think that's it. Test will be tomorrow, and I'll put this recording on Canvas in case you want to watch it again.
Take it Wednesday or something.
You've got golf tomorrow?